Hey there circuit gamers, on today's video we are going to show you how we made our color catcher game. It uses this pretty cool M5 ESP32 bot. We use Aruco markers, we have this LED matrix which we can control using the Raspberry Pi. There's a lot of pretty cool stuff, and the coolest is that it's all available for you to use as well. So let's go and check out how we made this game possible. So the goal of the game is to capture as many points as possible as the robot. Every time there's a block on the arena with a different color, you have to drive the bot there to get 1 point. The longer you drive and the more points you get, the harder it is to score a point, as there's less and less time for each block. These bots are pretty cool because they not only move forward, forward and back and rotate, but they also have omnidirectional wheels, which allows you to on the same spot start moving leftwards or rightwards. So you can just press a button and it starts going exactly to the right or exactly to the left without any turning or going forward. We have a huge Aruco marker which we use to identify the position of the bot. So this is the bot that you use when playing the game. It is controlled by an M5 stick, which is a ESP32 microcontroller that has Wi-Fi and is able to send commands to the bot itself. And the bot has a battery and 4 individual motors which allow it to drive in any direction, and also, since it has the omnidirectional wheels, also left and right. And this is how the arena looks under the hood. There's basically 16 of these 8x8 RGB LED grids, and each of these LEDs can be individually controlled. It has RGB, so we can set whatever color we want. So if you have an LED strip, this works exactly the same way, even though it's shown, it looks like it's a rectangular shape, but it works exactly the same way. And then it's connected using power, ground, and then we have a pin which we use to send data from the Raspberry Pi to the LED grid. Now, to make this game happen, we had to do a couple of different setups. First things first, we had to set up our Raspberry Pi with the Circuit TV SDK. Then we had to install the Arduino SDK on our ESP32 on the M5 stick. And then we had to set up the arena. So we had to program and create the code for the LEDs. And then we had to develop the code that would identify A, the location of the bot in the arena or on the camera, and B, the location of the game itself. So for that we use the Aruco markers, which help us identify the location of the bot in the area, but also its direction. And since we didn't want the game view to be a top-down but a bit angled, we decided to use 2 separate cameras. One camera for the image recognition, as it's best to have a top-down view, since then it's much easier for the camera to see the Aruco markers. But then for the player view, we added a second camera which we put on the angle on the side of the arena, on the side of the game, for the players to have a more immersive view. During the setup, we had a couple of interesting challenges that we had to figure out. First one was how to program these LED matrices. Now, as mentioned before, each of these are 8x8 grid, and we have 16 of these elements on the arena. We had to figure out how does this work, first and foremost. Surprisingly, it's very simple. So this is an 8x8 LED grid, but essentially it's 64 LEDs in a line. So when we have 16 of these, we just have a very long line of LEDs. And then to each LED we can send the number of which LED we're trying to program, and then we just send the RGB value, so the red, green and blue. And that allows us to set any color we want for the LED. So once we figured how the LED matrix works, we made a little script that basically is able to precisely tell from the Raspberry Pi to the LED matrix which LED should be programmed at a time. This allowed us to not just program and indicate when the game is ending or where the robot should drive next, but also add some cool animations, like when the game starts, we have a 3, 2, 1 countdown directly on the LED matrix itself. The second challenge that we had to overcome was to teach our Raspberry Pi how to use these Aruco markers. So we used an OpenCV Aruco marker library to interpret the location of the bot, and then to draw the actual game field. What we would do is we would take the bot or the Aruco marker, we would check the logs on our computer, and we would put it to different corners of the arena. So we would put it to one of the sides, we would see what are the X and Y coordinates, and then we would save them. We would put it to the next one, see what are the XY coordinates, and we would save them. And we would move it to all the 4, and then that would kind of let us interpret to the camera and to our code what is the location of the game itself. Once that was done, we also told our code what is the value of the Aruko marker on the bot itself. Here I think it's now 0 currently, so every time the camera sees 0 on the Aruko marker, it knows that that's the robot and that's the location of the robot. Once we figured out how to control the LED grid, that's the floor of the arena, and the Aruko markers to understand the location of the bot and the game field, we then had to write our game logic. The game logic is actually pretty simple. You start with a certain amount of time. By default right now it's 25 seconds, and then every time you catch a color, you get some extra time. However, the more colors you catch, the less time there is given to you as an extra. There is a hard limit, however, which is currently 4 seconds. So that is the minimum time you will always have to catch the next color. So we programmed all of that, but the cool thing what we did is we didn't just program it in the code itself, but we made it as custom configs. This allows me, without editing any code, to always change how the game behaves. So some of the basic things I can do directly from the admin panel is, for example, on the fly, change the color of the arena. So right now I just changed it from purple to blue, or I can change it to green, or whatever I want. So I can change how the game looks. I can also change the brightness and the accuracy of the game. So by brightness, I can change how bright are the LEDs. By the accuracy, I can set how precise should be the location of the bot on that active arena color. But I can also change the game logic itself. So for example, the initial time the player gets, how much time there is for the player to actually catch the color, what is the minimum threshold, what is the interval between the LEDs blinking, and basically every single parameter of the game. I don't have to go and edit any code. Since I define those parameters as custom game engine variables, I can just go to the game settings page and do all of that without editing any line of code. Once we finalized all the code and we started building the arena, we realized that there's one issue. Every time we would slightly move the camera, it would affect the gameplay. The reason for that is that we hard-coded the values of the arena itself, so where on the camera is the layout. So if the camera gets moved, then the whole game kind of gets moved. And to fix that, what we did is we added 4 extra Aruko markers to the arena itself. So you can see them on the sides of the arena, on all of the sides, and as long as 3 of them are visible to the camera knows exactly the position of the arena, no matter if you move it to different places or if you change something. And once we finalized developing all the code and adding the extra Aruko markers, we continued building the box itself and the arena. In essence, it's just 2 cameras inside. There's extra lighting since we're closing the box and it gets pretty dark inside. We have the LED matrix and the bot itself. We then wired the LED matrix with a 5-volt power supply. We powered the Raspberry Pi, connected all the cameras, and then we added the extra cable for the robot itself for continuous charging. This allows us to run the game 24/7. The box looks, as you can see, it's a huge wooden box. You can close it, then it's pretty silent. Nobody even hears it. And yeah, you can play this game whenever you want. To celebrate the launch, we are actually going to do a 1-month tournament with the people, top 3 who get the highest points on this game. We'll be winning some swag from our team. Stay tuned for the actual prizes. And yeah, this is basically the whole build. All of the code for this game is available on our GitHub, and for setting up this bot, you can find the documentation on docs.surrogate.tv. To set up the Raspberry Pi, you can check out our video. You should see the link there for how to set up a Raspberry Pi with Surrogate TV SDK. And this is basically the whole setup. Let us know in the comments below if you found this video interesting or if you have any other questions. Like it, share it with your friends, and we'll see you next time.